Welcome to my YouTube channel Janit for the JEE and NEET aspirants. So in the previous session, I have talked about how to calculate the center of mass for the point mass. So in the today's session, I will talk about how to calculate when the mass is distributed throughout the body. And then after that, I will talk about what are the general or standard result for the some particular shape. That means what will be the center of mass for the some particular standard shape. And then I will discuss whatever the problem which was asked in the JEE exam. See how to calculate the center of mass of continuous distribution of mass. Continuous distribution of mass. Okay. So suppose this is the body. Coordinate system are x, y, and z. If mass is if mass m is distributed, if mass m is distributed over a body, for example, it may be a rod, it may be a ring, it may be a disc in any shape. For example, a ring, disc, and rod. So what you will do, first of all, you will take a small element. Let us suppose this small element having a mass is dm, and this small element is located, and we can say that its position is r vector from the origin. From the origin. Okay. So for calculating the center of mass of this type of body in which mass is distributed, so what you will do, the center of mass can be calculated as the r vector dot dm divided by integration of the small mass dm. Okay. So this is for the r vector, means it will give you the x coordinate, y coordinate, and z coordinate if you are writing in the x, or we can say that I, j, and k cap. So if you want to simplify in the terms of x center of mass, x center of mass, that means it can be written as x dm divided by integration of dm. Ycm can be written as ydm divided by integration of dm, and zcm is nothing but zdm divided by integration of dm. So what is this dm? Dm is nothing but the mass of this smallest element. If you integrate throughout the body, then you will get the complete body mass. Okay. So that means for continuous distribution, what you have to do, you have to take a small element and then you have to integrate. Fine. What is this x, y, and z coordinate? Where x, y, and z, these are nothing but the coordinate of the center of mass of element. The element which you have taken, that basically this x, y, z is the coordinate of the center of mass of element. Okay. Now, I have already talked about how to calculate the center of mass of point mass. As you know that center of mass of point mass means which is nothing but summation of mixi divided by summation of mi. That means if the 3 point masses are there, then you can write as m1 x1 plus m2 x2 plus m3 x3, similarly divided by m1 plus m2 plus m3. These are the point masses. But if the mass is distributed throughout the body, so you have to use this concept. Use this concept. Now, a very important key point I want to mention, the main thing is how to get the value of dm. How to get the value of dm. That means nothing but the mass of the smallest element. So that basically defined in different way. So dm is nothing but the mass of element, mass of element. So if I will talk about in one dimensional case, that means linear. So it can be defined in terms of linear mass density, which is nothing but lambda dx. Okay. So this dm mass can be written as lambda into dx, where lambda is nothing but mass per unit length, mass per unit length. So the dm can be written in one dimensional as a lambda dx, where lambda is the linear mass density, which is mass per unit length. So if you multiply m by L and this is the dx, this is also a unit of length only, so you will get the mass. So from the unit perspective also you can check this relation is correct. Now if I will talk about in terms of or in 2D, the area you will consider. Okay, so this dm mass can be defined in terms of sigma into dA, that is nothing but areal density. So the sigma can be written as mass per unit area. So in the similar manner, if any geometry having a three-dimensional which basically contain a volume, so it can be defined as a volume density. Okay, so rho into dV. So the rho can be written as mass per unit volume, mass per unit volume. Okay, so let's take one example. So if the linear density of rod of length L varies as lambda is equal to a plus bx, okay, find the position of center of mass where x is the distance measured from one of the end. So what is the question? This is your, we can say that rod. Now you have to calculate the center of mass, position of the center of mass for this particular rod, in which the linear density, which is varying as a plus bx. That means the lambda can be represented as a plus bx, okay, which is nothing but the linear mass density, linear mass density. Okay, so what I will do again, I will take a small element which is nothing but dm at a distance of x. Okay, so this small element having a length is dx only, which contain a mass dm. So now if I will integrate from this origin 0 0 to complete length of the rod, you will get the total mass. So this small element, this is dm. If this rod is contains n number of small element dm, so if I will integrate from this point to this point, I will get the total mass. Okay, so that means the limits are varying from 0 comma 0 to L comma 0, because it is a one dimensional. So the x coordinate is varying from 0 to L and y will be 0 1. Now if I want to calculate the x coordinate of center of mass, what is the formula for a distributed mass? Just now I have discussed x dm divided by integration of dm. Okay, x dm divided by integration of dm. So x dm is nothing but, can I say the dm is lambda into dx? But here lambda cannot be written as mass per unit length. Why? Because the lambda variation is given as a plus bx. So you have to put the same variation. So sometimes they will give you in terms of area also. So you, in case of dm, it will become sigma into dA. So sigma value will you have to put whatever the variation they have given. Okay, so lambda is nothing but a plus bx into dx into dx. So if I will put here, so a plus bx dx divided by integration of a plus bx into dx. Okay, now very simple. You have to integrate only. So what is the limit? 0 to L, and here also 0 to L. And you know the integration, how to solve this integration. So first you multiply ax plus bx square. This will be the dx divided by 0 to L a plus bx into dx. Okay. What is the integration of x dx? If you will take the integration of x dx, that is x square by 2. Okay, so a x square by 2 The upper limit is L and lower limit is 0. Similarly, for this B, x cube by 3, because x square dx integration is x cube by 3, and the upper and lower limit is ln 0. So similarly, A x L0 plus B x square by 2 ln 0. Okay. You have to calculate the center of mass. So xcm, if I want to write down, which is nothing but the AL square by 2 plus BL cube by 3 divided by the AL plus BL square by 2. BL square by 2. So what I have done, I just kept the value of upper and lower limit. So you got the AL square by 2 plus BL cube by 3. Now you have to simplify this. So if you will take A plus BL common from numerator and denominator, so you will get as L square by 2 plus L cube by 3. Let me check this. Yeah, this is L square by 3. Similarly, here it will become L plus L by 2. So what I have done, I have taken A plus BL common from numerator and denominator. So you will left with this particular expression. Now you can simplify this. If you take the LCM, this is 6. This is nothing but 3L square plus 2L square divided by 3L by 2. Okay, so this is nothing but 5L square by 6, 2 divided by 3L. So you will get as 5 by 9L. Now you can check also the x center of mass, that means the coordinate of center of mass, it should be in form of length, or we can say that a meter. So you got this relation 5 by 9 into L. That means the center of mass of this particular rod, in which the linear mass density is given as A plus Bx, is nothing but at a distance of 5 by 9 into L. 5 by 9 into L. Okay. Now this is for we can say that rod. Now I will discuss the other geometry also. So the center of mass of a thin uniform semicircular ring of radius r. Okay, so let us suppose if there will be a complete ring is there, so the center of mass will be here. Okay, but if I am taking as a semicircular ring, what will be the center of mass? First of all, if you see this semicircular ring having the axis of symmetry is y-axis. Okay, that means the center of mass always exists over this particular axis only. That means you have to calculate what is the y coordinate of center of mass. Okay. Now what you will do, again the same thing, you have to take a small element, then you have to integrate from the initial position to the final position. So what is the condition given? The semicircular ring is given. Okay, semicircular ring, as you know, that has y-axis of symmetry. Y-axis of symmetry. So the center of mass will lie on that axis. Lie on that axis. Lie on that axis. That means the y coordinate of center of mass, how you will calculate? Y dm divided by integration of dm. Now you have to first of all consider the dm. What will be the dm mass? Okay. So this is basically a semicircular ring. What I will do, I will take a small element at an angle of theta, and this small angle, the small element which is making angle of d theta at the center. Okay. So can I say the dl value is nothing but the r into d theta, because r is the radius of semicircular ring, and this small element is basically making a d theta angle at the center. Okay. What is y? Y you already know. Y is nothing but this is nothing but y coordinate of center of mass of element. Center of mass of element. That means whatever the small element which you have taken, okay, what will be the y coordinate of this particular element? Now you have to calculate the dm mass. How to write the dm mass? Lambda into dx. Okay, what is this lambda? Lambda is nothing but the mass density only. So can I say, if this complete semicircular ring having a mass m, What will be the length? So complete ring having a 2 pi r. So for this particular halves, or you can say the semicircular ring, the length will be pi into r. Okay. So as you know that dx means this is a small element. Okay. So the dx is nothing but the r into d theta, which I have already talked about, because the small element means I have taken a this small element. You can see it is a very big, but element will be very small. Okay. So the dx value will be r into d theta. So dm value you have calculated. Now the main thing is how to calculate the y. What will be the y coordinate? Okay. So if you simplify this dm value, which is nothing but m by pi into d theta, what will be the y coordinate? So let me take the same element. So this is a element which is very small. Okay. It is making an angle of d theta at the center, and this is nothing but the theta. So if I want to write down, the x and y coordinate, can I say this is basically r only? This is r only. The radius will be same. So r of cos of theta will be x coordinate, and r sin theta will be r cos of theta, and this will be r sin of theta. As the theta will change, the x and y coordinate value will be changed. So for example, if theta is basically 90 degrees, so I am talking about the coordinate of this point. Okay. Now, in general, what is the y value? So I can write the y center of mass can be written as r sin theta. Dm value you have already calculated, which is m by pi d theta, divided by integration of m by pi d theta. Now, a very important thing, what is the upper and lower limit of theta? Because the theta is only changing, that is the variable. So we can say that the theta is varying from this 0 to pi. So that means the lower limit is 0 and upper limit is pi. So now if you integrate this m by pi d theta integration theta, so you will get, this is nothing but the r m by pi I can take as a common. Okay, from the numerator, r m by pi I can take as a common here, and m, this d theta integration is theta. So upper and lower limit is pi minus 0. So pi will cancel out. So you will get the m only. Okay. Or if you want, I can write as a here. This is nothing but m. So what is left from 0 to pi? It is left with the sine theta d theta. Now you have to integrate the sine theta from 0 to pi. What is the sine theta integration? Minus cos of theta, and it is varying from 0 to pi. So this will be also cancel out. So you will left with the r divided by pi minus of cos theta from 0 to pi, minus of cos theta from 0 to pi. So cos pi, if you will put, this is nothing but minus 1, it will become positive. Okay, and the same cos 0 is 1. That means you will get as, let me take this little bit above. That's fine. So you will get as minus r by pi. Cos pi is nothing but the minus 1 minus of cos 0, because I have taken minus common, so this will be minus 1. So you will get as 2r by pi. Very important relation. Okay, then after that I will talk about how to get these values by the simple tricks. Okay, so this is the expression for how to calculate the center of mass of uniform semicircular ring having a radius r, which is nothing but 2r by pi. That means this y center of mass I have calculated, which is nothing but 2r by pi. Fine. Now if I want to calculate the center of mass of semicircular lamina, okay, it's not a ring, we can say that it will be a form of plate. How to calculate this value? So again, what we will do, we will again take a small element. So I have taken a small element at a radius of r, whose thickness is dr. So if I want to calculate the center of mass of this semicircular lamina, so again you can write as YCM is nothing but YDM divided by integration of dm. Because this is symmetrical about the y-axis, the center of mass will be always lie on this axis only. Now, this is basically a lamina. Lamina means having an area. So here the mass, that means define the dm mass, we have to use the areal condition. That means sigma into dA. So dm mass is defined in terms of area. So sigma into dA. What is sigma? Mass per unit area. So total area will be pi r square for a circular lamina, but it is a semicircular, so that means it will be pi r square by 2. Okay. What is dA? If area is this one, so dA will be pi r into dr, pi r into dr. You just differentiate also, then 2 pi r, the 2 will cancel out, pi r into dr. Now, the dm mass you have calculated as, which is nothing but 2m divided by r square, pi will cancel out, and this is r into dr. Okay, r into dr. Now, what is the y? You already know for a uniform semicircular ring, what is this y value? Just now I have discussed 2r by pi, 2r by pi. So here I have talked about the complete radius. Now I am taking a small ring at a radius of small r. That's why this r is used. So y is nothing but 2r by pi. Fine. So lamina, that is nothing but the semicircular lamina. Okay. So the integration of dm will be the mass only. What is this value? This is nothing but 2r by pi into 2m divided by r square into r into dr. Okay. So otherwise you can take this dm also, this one. Okay. And if you integrate, again you will get the complete mass, because this is nothing but the mass is distributed over this complete area. This is 1 by m, 1 by m. So now this r is varying from where to where? This 0 to complete r. So the variable is r only. So 0 to r. Now if you can take a common, so this is nothing but 4m, and here will be pi r square, pi r square. So now the integration left is 0 to r into r is r square dr. So this m will cancel out. Okay. Now if you solve this, then you will get as 4r by, because r square dr is r cube by 3. So 4r by 3 pi. That is nothing but the center of mass of this circular lamina. Okay. So you got the center of mass for this semicircular lamina is 4r by 3 pi.